everyone! So today we're going to be talking about 0.2, which is just a review of linear inequalities from Algebra 1. So we're going to be graphing linear inequalities. So as you can see in this box here, we have an inequality x is less than -4. So if we wanted to graph this, we're just showing on a number line the set of points that represent all solutions to that inequality. So to do this, we put -4 on our number line here, and then we think about the numbers that would need to go to the right of that and to the left of that. Well, as we go to the right from -4, we're going towards positive infinity. So we're wanting to get increasingly positive numbers. So towards 0, we are trying to go, so -3, -2, and then towards the left from -4, we're going towards negative infinity. So increasingly greater negative numbers, so -5, -6. All right, and so then to actually graph the inequality, since its x is less than -4, we draw an open circle at -4, and we draw an arrow towards all the numbers, or through all the numbers, I should say, that are in our solution set. So -5 is less than -4, -6 is less than -4. So we want to draw that arrow towards a negative infinity. All right, and so notice I used an open circle, and that's because it's less than. So you use an open circle for less than or greater than, and then you use a closed circle, so you would have just filled in that circle, for less than or equal to or greater than or equal to. All right, and then to write the solution in interval notation, that becomes a little easier once you can see it on the graph. So interval notation is just a way of writing the solution as an interval. So you are going to put it either in parentheses or in brackets. So here it's actually parentheses, and that's because the solution can go, it can't go any further right on the number line than -4. So the furthest right number on the number line is what goes to the right of the comma in interval notation. And then you want to think about how far left that solution set is going. Well, it's going off the number line, and it's going from -5 to -6 to -7 to -8 to -50 to -1000. It just keeps on going. It's going towards negative infinity. So we put that on the left there. All right, so notice I use parentheses. Parentheses indicate not included. So when it's negative infinity or positive infinity, you're always going to use parentheses. You can't contain infinity, so always use parentheses around negative infinity or positive infinity. But notice I also use parentheses around -4, and that's because x has to be less than -4. It can't actually be equal to -4. So -4 is not a solution of the inequality. So you have to use parentheses there to denote that -4 is not actually a solution. -4.00001, that is a solution. -4 is not. And then brackets indicate not included. Or sorry, brackets indicate included. And so if this said x is less than or equal to -4, x could actually be equal to -4, and so this would be a bracket here instead of parentheses. All right, so let's take a look at this first example here. X is greater than or equal to -7. So again, we put -7 on our number line. Think about what numbers need to go to the right and to the left. So to the right, we're going in the positive direction. So we're getting closer and closer towards 0 as we go to the right. And then towards the left, we're going towards negative infinity, so increasingly negative numbers. Here, it's a closed circle because x can actually be equal to -7 because its x is greater than or equal to -7. And then we want numbers greater than that. So we draw our arrow towards a positive infinity. And notice that arrow that we just drew on our number line, that arrowhead actually matches the symbol. So that's kind of nice to check ourselves. And then interval notation. So again, what's going on the left side of the interval notation is the number furthest left in the solution set on your graph. So -7, notice, is the furthest left you can go and still be a solution of the inequality. So -7, and then the furthest right number, well, there's not an actual number that this arrow is stopping at. That arrow is going towards positive infinity. So that is what's going to go on the right side of interval notation. And again, you can't contain infinity, so it needs to be parentheses around infinity. And then since -7 is actually a solution to this inequality, it's going to be a bracket around -7. And that's because x is greater than or equal to -7 in this case. All right, now I want you guys to pause the video and try number 2 on your own. All right, now to solve inequalities. So you solve an inequality just like you would an equation. But if at some point in solving that inequality you have to multiply or divide both sides of the inequality by a negative number, you must reverse the sign. So if it's a less than sign, it becomes a greater than sign. If it's a greater than or equal to sign, it becomes a less than or equal to sign, so on and so forth. So let's try this first equation here. So think about it as if it was just x over 2 minus 5 equals 7. Well, we're trying to solve for x. So we would move 5 over to the right by adding 5 to both sides. So we get x over 2, carry that inequality symbol down the whole time. So x over 2 has to be greater than 12. And then to isolate x there, we would multiply both sides by 2. So x is greater than 24. All right, so that's what we're putting on our number line. As we go to the right, we're going towards positive infinity. As we go to the left, we're going towards negative infinity. And we're going to do an open circle at 24 because it's not actually, x can't actually be 24. It can only be numbers greater than. So we're going to draw our arrow to the right. All right, and then interval notation. Again, the left side of the interval notation is going to be the furthest leftmost number. So that's 24, which is not included in the interval. So we're going to put parentheses around that. And then the solution is going off towards positive infinity. So the interval notation is from 24 to positive infinity. All right, I want you guys to pause the video and try number 4 on your own. Remember, if you multiply or divide both sides by a negative number, you must reverse the sign. So don't forget that when you do number 4. All right, I quickly just wanted to go over some special cases when you're solving inequalities. So 1 and 2, 3 and 4, we're going to solve just like we were in the last 2 examples. So in this first example, we're going to solve it like it's an equation. So we're going to use the distributive property, distribute that 3 to each term, and then on the right side, distribute that 4 to each term. So we get 24x minus 27 is greater than 24x minus 4. All right, so we're trying to isolate x. So we have the variable on both sides of the inequality. So we want to move 1 over so they're both on the same side. So if we subtract, let's say, 24x from both sides, oh, but notice it's the same amount on each side. So when we do that, we get negative 27 is greater than negative 4. So you want to think to yourself, is that a true statement? Is negative 27 greater than negative 4? Well, no, it's not. Negative 27 is actually less than negative 4. So that's not true. So there's actually no solution to this inequality. And you can just draw that as a circle with a slash through it. That's like an empty set. That's notation for an empty set. All right, number 2, we would solve like normal. 11x minus 4 is less than or equal to 6x, and then distribute that minus sign to each term. So minus 3, and then negative 1 times negative 5x, that's just plus 5x. So we get 11x minus 4 is less than or equal to, combine like terms, so 6x plus 5x is 11x. So we get 11x minus 3 on the right-hand side. So again, we have that 11x on both sides. So when we subtract it from both sides, we get negative 4 is less than or equal to negative 3. Well, is that a true statement? Yes, negative 4 is less than or equal to negative 3. So that's true. So it doesn't matter what x is, that it doesn't matter at all. This is always going to be true. And so the solution set is actually all real numbers. And so to graph that, you just draw a double-headed arrow on the number line, showing that all the way towards negative infinity is a solution, all the way towards positive infinity is a solution. And then to write that in interval notation, it's just negative infinity towards positive infinity. Again, this is all real numbers, which you will often see this symbol, a double-stemmed R, to represent all real numbers. All right, I want you guys to pause the video and solve number 3 and number 4 and see which one is all real numbers and which one is no solution. And you guys do need to be able to identify which case is which. If it's a true statement, if it's a true inequality, then your solution is all real numbers. If you end up with a false statement, a false inequality, your solution is none. It's no solution. All right, so next we're going to talk about compound inequalities. And these just contain two separate inequalities that are joined by and or. And often when they're joined by and, it's really an implied and that's joining them. But we'll get to that in a second when we talk about type 2 compound inequalities. But first, let's talk about type 1, ones that are joined by or. So here we have an inequality. And notice now we don't just have one arrow, we have two arrows. So we've got the inequality, well, if this was just one inequality, this would be, if we're talking about x is less than or equal to negative 4. But also notice that we have a second inequality here. X is greater than 1. It's in between 0 and 2. So let's call this 1. So this is a second inequality represented on this graph here. But notice it doesn't need to be both. So notice like 3, for example. 3 is a solution to this second inequality, but 3 is not less than or equal to negative 4. So this is a compound inequality that we would join with or, because it's one or the other. X can either be less than or equal to negative 4, or it can be greater than 1. All right, in interval notation, we now have two intervals to write. So negative infinity to negative 4 brackets, union, which just means or, 1 to infinity. So the solution is any number that's in between negative infinity and negative 4, or in between 1 and positive infinity. So to solve this type of compound inequality, you solve each part and then graph on a number line to show the solutions. The graph is just the solution set that fits at least one of the inequalities. All right, type 2 and compound inequalities. So notice now it's not really a line anymore, it's a segment going between two numbers on the number line. In this case, going between -2 and +5. So x has to be greater or equal to -2. But notice it also has to be less than 5. So that's why it's and now. All right, for and inequalities, you guys are most often going to see them in the condensed form. And the condensed form is just combining both inequalities into one. And to do that, you put the leftmost number of the solution set. So in this case, -2. And then -2 is less than or equal to x. So what we did is we essentially wrote this first inequality in reverse. So instead of x is greater than or equal to -2, we wrote it as -2 is less than or equal to x. And then we know x is also less than 5. So that second inequality gets tacked on as well. So this is called the condensed form of that compound inequality. All right, and then interval notation, again, is just writing it as an interval, all the values that this compound inequality can take. So it can go from -2 to +5. -2 is included in the interval, and 5 is not included because x has to be less than 5. So that is interval notation. All right, to solve these types of inequalities, if the and inequality is actually written out, you could just solve it each part separately. If it is condensed, you can solve it all together working inside out. So I will show an example of that so you aren't just hearing it in words. And the graph is just the solution set that fits both of the inequalities. All right, I'm going to do 1 and 4, and then I'm going to have you do 2 and 3 on your own. All right, so 1 is a compound inequality joined by or. So you just, like it said, solve each one separately. So add 4 to both sides. 2x is less than 12. Divide both sides by 2. So you get x is less than 6. All right, so find 6 on your number line. It's an open circle because it's less than, and our arrow, since it's less than, is going towards the left. And then we have to solve the second inequality. So we add 3 to both sides. So we get 5x is greater than 40. Divide both sides by 5. We get x is greater than 8. And so an open circle again at 8. And then that second arrow is going to go towards the right because x is greater than 8. So notice, or compound inequalities often have two lines going in opposite directions, going out, versus compound inequalities joined by and is often just a line segment, a segment going between two numbers, going towards each other. All right, so number 4. Number 4 is a condensed form, so you don't actually see and written in the inequality, but you can see that negative x minus 2 has to be greater than or equal to negative 4, and it has to be less than or equal to 3. So to do this, we're trying to isolate the variable in the middle. So we're trying to isolate x, so we're going to do that using inverse operations. So whatever we do to the middle to isolate x, we have to do to the right-hand side and the left-hand side. So don't forget that. Do it to both sides. So we get negative 4 plus 2 is negative 2, is less than or equal to negative x, is less than or equal to 5. All right, so then we have a coefficient of -1 on our x. So we are going to divide all three sides, all three parts, by -1. So -2 over -1, negative x over -1, 5 over -1. And remember, when we divide or multiply by a negative number, when we're solving inequalities, we have to flip the sign or reverse the sign. So -2 over -1 is +2. And so instead of is less than or equal to, you reverse that sign. X over -1 is just x. And then 5 over -1 is -5. And again, we have to reverse that second inequality sign. So let's kind of reverse this. So we're going from the most negative number to the most positive number. So -5 is less than or equal to x is less than or equal to 2. So we draw a closed circle at 2, a closed circle at -5, and the solution set is all the numbers between those. And so we draw a segment from -5 to +2. And the interval notation for that is going to be -5 to +2. Brackets because it's less than or equal to. And I just realized I did forget the interval notation for the first example, and that's important, especially because you guys probably aren't used to writing union with your intervals. So the first interval, so if you're just looking at kind of the leftmost inequality, that interval is -infinity to +6, not included. And this second interval is 8 to +infinity. And again, you join those two intervals with a big U for union. All right, so now pause the video and try 2 and 3 on your own. All right, lastly, writing compound inequalities. I'll do the first and third, and then I'll have you guys do the second and fourth on your own. All right, so that first compound inequality, notice the arrows are going out. So this is probably going to be an or compound inequality. So notice x, this is -1, and so x is less than -1, or x is greater than or equal to 5. And you do just want to like take a second after you write it to think, oh, does that make sense? Does it make sense to join those with or? And it does. X can be less than -1, as you can see on the left side of the number line, or x can be greater than or equal to 5, as you can see on the right. So that's the compound inequality for the first graph. And then number 3, now we have a segment, so the arrows are not going out. So I'm suspecting that this is going to be a compound inequality that should be joined with and. So notice x, again, that 1 is in between that -2 and 0 there. So notice x can be greater than -1. Sorry, I said 1, but it's -1. X can be greater than -1, and x also has to be less than 5. Less than or equal to 5, since it's a closed circle. And so this is when you would say and here, because it needs to be both. It can't just be greater than -1. Otherwise, 8 could be an example, because 8 is greater than -1. But notice it's not in the solution set because it's not less than or equal to 5. On a quiz or test, I would most likely ask you to write this in condensed form. So you're going to have to combine these into one inequality. And so to do that, you write the furthest left number first, and then flip that inequality symbol. put x in the middle, and then you don't flip that second inequality symbol. X needs to be less than or equal to 5. All right, so pause the video and try the other two compound inequalities.